In a previous video, I introduced this find object of type, and this code runs every time a new enemy is spawned. So this is definitely something we really don't want. So we're going to do a few things here. One thing also is that because it's a pooled behavior, we're going to want to check if this thing already exists before adding it. Right? So that's one of those deals. Um, so yeah, so we got that. I'm gonna put this down here. All right. So we want to get rid of find object of type. If you remember from a previous video, we unit tested the idea of the target, not being there. So removing this will reintroduce the problem, but we want it to remain decoupled. And so uh, there is a targeting system, and enemy bot targeting. And in that targeting system, basically what it does is it goes through and finds all of the targets and then sorts them by priority. So enemies will, uh, find things to fight against based on what their priority is. This is probably really overkill for this project because I don't have a lot of enemy targets at the moment, but it may come in handy, say, if I add other minions you can control during the game. So we want to kind of get it to work with this system. And what's really nice is that there is a action here. It's pretty decoupled, and it just says it takes a transform, which is the target, and it just says on targeted. So I can actually find when that target gets found. So what I think I want to have happen is our original code there should probably just use that system internally. So we're going to go ahead and delete this line, and we're going to go in to one of these locations here. And this is the class that we've been unit testing and building up through TDD. So kind of what we'll end up with is on enable binding, finding and binding to the enemy bot targeting, and setting our target that way. Luckily, there's some unit tests that we can modify. So in the tests that are referenced here, we can basically reuse this one, because now this is going to fail. Actually, it won't fail because it's just setting the target. So we probably do want a new unit test that verifies that the binding happens. And actually, with the changes that we made, we should be able to see whether or not something fails. So let's go ahead and do that. Because we didn't change any tested code, actually. So that would have, yeah. So now we are, we basically want to write the task that will force us to change the code. And one way of doing that is to also include the integration of the bot targeting system. I like how simple this test is, so I'm going to duplicate it, and then we're going to, again, we'll just name this foo, and we are going to remove the target, the setting of the target, and we should hopefully see foo fail, because now it won't move to the new location, and therefore is broken, right? And we see that we wanted to, it was expected not to equal, but it was identical. So that is the problem. Okay, so we know that we want our enemy to also have a enemy bot targeting. So equals enemy dot add component, and we're going to do an enemy bot targeting. Yeah, and so this thing is essentially going to be calling all kinds of stuff, and you know, adding targets and finding all and things like that. So we have this enemy target manager. This thing has a bunch of enemy targets in it, and it's a public property of this class, so it just gets initialized as part of the setup. But what that means is we can actually give the enemy target manager the enemy, and then it could go in and find its priority based on that, and then theoretically call on target. So you know, that's a lot of theoreticallys, and so we're going to be kind of just digging down. There's a lot of legacy code in here. That's code that's not tested, that we will need to dig through to write this test properly. But so for now, we have the targeting system. We've called on enable. That targeting system should you know, basically have a way of finding that player. So I happen to know that if we do you know, enemy target manager equals new new game object dot add component enemy target manager. This thing we can just say dot add something along those lines. It's internal, so we're going to make all of these internals into public, and go back so we have access to it. Dot add. So in here we are expecting to get an enemy target, which means our player object dot let's see, var enemy target equals player dot add component enemy target. This also kind of unit testing gives you this idea of like how many dependencies you have, etc., etc. So we know the enemy target. So this enemy target manager now has a reference to that target, and then targeting dot enemy target manager. This means that we don't have to call find all targets every time because they register themselves with this comment class equals this enemy target manager. So now when we call on enable, we could set it up. Oh, and in fact, let's see, warp.update. So enemy bot targeting will also, we will also need to cause it to find a new target. Oh, and in fact, we can just call find new target and bypass the update loop. So what we will do is go back to our test. And once this is all set up and we've called on enable, then we should be able to say enemy bot, enemy, or sorry, targeting dot find new target. So that will then cause us to get the reference to the target, throw it in there. Yeah, so then we'd be forced to kind of register it and then go there. So here we are. We will run that test and see how it fails. Bam, run all. And we have a null reference exception. Let's go ahead and take ourselves to that line. Oof. AI. So our AI is our AI character controller. So, and that's get components in get component in children. And then, so because it just needs that for the targeting system, and so this might be a little bit too tightly coupled. We're not going to fix that right now because we want to have unit tests anyway. So instead, we're going to adjust the test to account for that by adding a AI character controller on a child component of the enemy. So we're going to be like var enemy child component equals new game object. Right, enemy child component dot add component, one of these. And we might not have reference to this DLL, unfortunately. So we're gonna have to do some modifications to our project again. But just to wrap this up, enemy.transform.parent, enemy child component.transform.parent equals enemy.transform. So this will allow us to set it as a child. So this AI character control, that's inside the standard assets, which is now its own separate DLL. If you looked at my video on the project setup for the tests. So what we do need to do is go and find our testing project. So here. And we have our edit mode tests. Oops. I'm going to close that, go back. In our inspector here, we are going to need to have the standard assets in there. And then we're going to go down here and hit apply. Sorry, I can't see that from my video. I need to block that area where my face is out of the videos. So heading back over. We should see that this begins to understand what it is again, unless there's an error. Still clear. Character controller cannot be found. Oh, maybe because we need an import. Yeah, so the import now exists. So there we are. Let's try it one more time. May still have a bit of trouble with this because the AI character controller has its own dependencies as well. Run all. Who is failing? Hopefully for not the same reason. Hey, it is kind of the same reason. AI character control. Why didn't... Oh, it never got an on enable called. And that's a private property. So we could just say on enable on that guy. And we should be there. But this will need to be public. So head back over to our test. So we're gonna also say let's see, var AI equals that. I'm gonna say AI dot on enable. No. We needed not the AI, but the enemy bot targeting. Yeah, enemy bot targeting. So it's be targeting dot on enable. All right, so that will allow it to capture the proper reference to the child object in the get component. And yep, hey, we got all the way through the execution. And failed on the position changing. So our test is failing for the correct reason. We're going to just jump into the warp. So here we're going to have to say something like targeting equals get component enemy bot targeting, which might have something missing. Namespace that I had for game scripts originally. Then we are going to make that into a field, I think. Field target. Oh, targeting. And what we need to do to make this all work is on targeted needs to target change. I think that's probably a better name for that. And new target. And now we can set target a new target. Okay, so basically what we did is we added a handler here. We're going to need a test also that will prove that we've removed that later. But for now, we're just going to try it out. And here we go. Again, please go tell people about Skull Survivor as we do this stuff. And any other game that I might be working on. Okay, so we're going to run. And, oh, I broke something else. That's fascinating. All right, but we did not move still. So let's go and figure out what might have happened there. So called on enable, we called warp on enable. Oh, the target never changed. So finally, once that's all bound up, we say targeting dot that's because find new target should have been called, and then find new target should have found our target, but then it starts a coroutine target after seconds. Yes, coroutines. That is not great because that would cause us to have issues with our targeting, because then we would set the target. So I'm thinking of bypassing this a little bit. On prospective target, time to get target, wait for seconds, prospective target equals this, targeted by this. Yeah, so find new target is actually going to just get a list of potential targets. And then it will eventually ask us to target after seconds. So we can kind of short circuit this, or we can have the target change, just extract that as a value. And I'm thinking about doing that. So I'm going to extract a function there, and let's see, target equals prospective target. Prospective target is targeted by this, and say, okay, so we're going to just say target, yeah, so we're going to say something along the lines of enemy target, new target, and we're going to just change this here and then this here. Whoops. So this is all logically the same, and we're just going to pass in prospective target here, and we're going to just say target enemy target, or set enemy target. Okay. And then we can make this public, and we're just going to use that as a way to bypass that. It doesn't help us actually. Yeah, we kind of want it to still fire that way. So what does that mean for us? So that means that we want to emulate the coroutine instead, maybe. Because we know the coroutine is getting called. No, we want that, but we don't want that. Okay, so let's go back to this. And yeah, I wonder how, I mean, we can just iterate over this, and we should see that come back from the enumerator. So maybe, or we set up the coroutine to maybe fake that coroutine, because I think we're just not getting here. All right, let's give it a shot. So This is the fun of live programming, because you also get to see me struggle with some of this stuff as well. All right, so we've bound everything. We said find new target, and then we go all the way, and we have the coroutine. It returns a coroutine. It's calling mono behavior start coroutine. And so, we have the real version, and then, we may want to deal with a unit testable coroutine. So yeah. Okay, so we are going to essentially make a testable coroutine. So testable timer. So this is kind of a static class that I'd set up. And I kind of want to do the same thing, but this would be like testable coroutines. And we're going to swap them out for essentially, testing coroutines. So I'm going to do a public static class, and it's going to be a what is this? It will essentially take in a function that takes a coroutine, an enumerator, and then runs it. And so we're going to just say testable coroutine. And what we're going to do is public static func, actually action of I enumerator. And we're going to just call this coroutine action. And it's going to equal, and then it's going to go to mono behavior dot start coroutine. Ooh, brutal. Delegate I action takes through arguments bias. And that's because, oh, actually it would, yeah, start coroutine takes an argument. Yeah, okay. So coroutine, and we just pass it in here. And so this will just forward it to the real thing, right? And what is this saying? Model behavior is a base class. An object reference is required for non-static fields methods. Brutal. Okay, so we are going to also take the sender. So we're going to just say mono behavior, comma, enumerator. And we're going to just say something like sender, comma, coroutine. So now we can just say sender.start coroutine, right? So this thing can be replaced with our own version of coroutine. And I'm going to just say something like public static switch to sync synchronous coroutine. And this thing is just going to say coroutine action equals sender, comma, coroutine. And we are going to set that. And in here, routine dot move next. And this might make the tests run forever if it's an infinite coroutine. But yeah, we're just going to iterate over them, and it will just keep firing and going through the coroutine. So we should be able to just have that run. Let's have a return public static void. Okay, so this thing will just iterate over them. So now in here, when we say testable coroutine dot coroutine action, we should call that start coroutine. Let's see, testable start coroutine. Yeah. All right. So now no argument given that corresponds. Oh yeah. So and then we would say this comma start. Yeah. All right. All right. So this thing now does the same thing that it did before, but we can swap out the functionality to then iterate over that. And so yeah, hopefully that helps. Moving it to its own file. And we are going to then head over to our test. And up here, we're going to just say testable coroutine dot switch to synchronous coroutine. Maybe for testing. So that'll swap over to our while loop here, and so then we can, fake that out. Okay, so let's go back to our test runner. This got more complicated really fast. Let's run those. And on set destination can only be called on active. So, hey, let's see, it can only be called on active agent. Sorry about that. There you go. Active agent placed on a nav mesh. Yeah, okay, so we're now getting exceptions that are based on that. And why is that? Because everything fired properly. And so now when we changed our target in enemy bot targeting, we called set destination somewhere. Destination. Which is somewhere else. Navmesh agent. So the AI character controller setting its target. Yeah, so because we're not decoupled from the AI character controller, we now are calling set target on that, which then calls set destination. And we don't really care about that so much. So it's almost as if we need to figure out a good way to decouple these things from each other, and that would be a good refactoring, because really the targeting system should not care about the character controller. Yeah, so AI targeting, target.transform. Yeah, and clear target should probably call on targeted and then clear it and so on and so forth. So everywhere that AI is called in here probably just needs to be somewhere else. Which is fascinating. Enemy bot targeting, and then yeah, so maybe that refactoring is another video, but we can close this out probably by changing this up a little bit. So we do want it to find the new target. Okay, so what are the things say? Set destination can only be called on an active agent that has been placed on a nav mesh. Use the Unity engine test tools, log, assert, expect. So I guess we can just take a look and see why we're calling the destination set destination, and then maybe we can change that up a bit too. So set target. So ensure agent target gets set. If not, agent is active and enabled, then return false. And so the agent itself, yeah, so disabling nav mesh agent will allow us to just bypass that. So we're going to say nav mesh agent that's set actor enabled equals false, and that might do it for us. Nope, still got there. Alrighty, warp targeting on enabled, find new target, warp to expected destination. Actually, we are just going to decouple this. So we're going to do kind of a new class here, public class, enemy bot targeting AI character control. Yeah, also mono behavior. And this will just be another component. It will require component type of targeting, and we're just going to start pulling this out of here. This way we don't actually need this going forward, and the targeting system will handle it, and based on targeted. So basically we need to get all these messages set. So set target would need to be here as well as here, or the on targeted whenever set target gets called. So clear target, and yeah, so set that to null. All right, so these things all should be available again. So on enable, we're going to say targeting equals get component of enemy bot targeting. And then we're going to throw this in here, targeting. And again, we're just kind of working with legacy code, so we're going to kind of split this out quite a bit. And we'll just say targeting plus equal dot on targeted plus equals on targeted. And then we're going to drop this in there, target. And basically, we're just going to remove all those references now. So this AI.set target now, you know, we're actually AI underscore AI equals get component. And then this is AI character control, right? And actually it was a get component in children here. So we're going to just make sure that that's identical. And we can just say AI.set targets equal to targets. And this is probably a breaking change, so we're going to have to like go and clean this up basically everywhere and make sure everything works. Set target is null. Oops, target, set target is null. Null. So, so target is null, so I gotta do target. Oof. That's gonna be null again. There. This thing will get forwarded through on targeted and on targeted. Okay. So all these things. So I gotta make sure that the game still works after this. And we do that. And we're gonna throw this into its own file. And so now these things should not cross-contaminate each other anymore. But we are going to need to go through and just verify. And actually, there might be one good place to set this, which is where we set up the targeting. So enemy bot targeting, because each of them have an AI character controller on them. And so we can just be sure to add that. And so we can just say var AI equals long variable dot get component and that and long variable dot add game object add component that. So this thing will just make sure that if it doesn't exist, it gets added and on the spawn there. So we can just try this out in the game to make sure that it continues to work and go from there. So we need a semicolon here. No, we don't need a semicolon there. Why is it complaining at me? Clear. Type space. It knows about it. Oh, here we go. So let's just see if our enemies continue to work. As we think, this will kind of need some regression testing, unfortunately, just because I did that all without backing tests. But that's kind of what we're doing here, is making sure that, yeah, so they are finding the target and chasing after. There are some errors though, so let's pause for a second. Null reference on enemy bot targeting. That's on targeted, and that came from a spawn and circle on 103. Pooled mono behavior. Yeah, maybe they might just need those on them. So we'll try it again just on the skeleton prefabs, and that would allow us to, so in skeleton swordsman, just throw one of these on here. You'll have it from the beginning, and I think that's what that error is coming from. So we'll check it out, see how it goes. Again, wishing that this type of unit testing was available at the beginning of the project. That would have been real helpful. Pool prefab, instantiate. All right, so it's just not liking us when we're creating the prefab. Yeah, we're just trying to spawn one. We know that. 103 again. We are just trying to fire, and then enemy bot targeting 38. Oh, target. Oh, yeah. That is silly. Okay. That's a good point. Let's head back again. Yeah. Bet you didn't expect to see manual testing during a unit testing video, did you? Yeah. So, yeah. I do not. No, there was one error, but I think it was just one of those silly object. Oh, okay, so that is just something else. Alrighty, so and then these errors, okay, the warnings. Okay. So we definitely have yeah, definitely seems to be working. We'll get some upgrades, kill off some guys, see how that goes. Seems to be going okay. And then from the beginning of this video, we were talking about making sure that we can't get too far away from our enemies without them respawning. And it looks like if you look up at the top there with the red lines on that nav mesh, it does appear to be warping them properly. So that was successful. So we are going to now finish our test. So that was the whole point of that. Run all. Hey, passing. All right, now we just got to find out why this guy is failing. Null reference exception on target created. And that's because we don't know if we're going to have an enemy bot targeting, because we don't want to necessarily use a script in that scenario. So I think that if it's null, then we don't do it. And that would probably be fine because we don't need this anywhere else. It's just for setting our target. So targeting dot, or just say if targeting is null, return, just a guard clause there. All right, so that should get our other tests to pass again. Another, it's all decoupled from each other. All that stuff should work. Yep, good. And in here, we are going to say finding new target sets target for warp. Right, so that all kind of works properly. I guess the last bit is that we need to make sure that we're calling on disable. So we need a test to tell us that we need to remove that handler on disable, right? So I think the last little bit is, maybe we can just count the count the handlers, that way we can just verify whether or not they were sent. And so yeah, so there's an event of get invocation list. So yeah, we can try that. And actually, maybe we should just assert dot r equal that. Actually, let's just even see if it's available. So targeting dot on targeted dot get invocation list dot length. Oh, beautiful. Okay. So what we can do is we can say, that we want to just ensure that we removed them all. And so we could just say something like warp dot on disable. So we're going to call it a function that doesn't exist yet, and then we're going to assert that are equal 0 and like. So disable, we want to basically prove that disable did not. So we want to get the code compiling, and we're going to remove this exception, and we're going to show that the test fails. I'm going to just move it up here. We're going to show the test fails, and then we're going to show a pass, and that will be the end of this installment, which has become quite long. But it's good because we got some decoupling going and all that. So it was expected to be 0, and in fact, yeah, it's not going to be 0. But we are going to take a look here. So we're going to just now be sure to call this because we know we're supposed to. And we're going to make it a minus equal. And it's still going to fail because something else in the test has added an invocation, which is okay. So we want to just say something like, and we're probably going to put this assertion in here as well to make sure that it was added. So it was 2 after our on enable. We ran the update, we disabled it, and now it's 1. So that was just assuring proper cleanup. Probably needs to be its own test maybe, but gonna run that, and bam. Okay, thank you very much. Like, subscribe, share, comment. If you have any questions, please feel free to hit me up. Twitter handles in the description, as well as everything else out there. So see y'all next time.